So I do need this, or only through this? Ah, okay. Ah, so I do need to speak to this. Ah, okay, cool. All right, so my name is Edgar, and this is my first ACAT, so bear with me. I'm trying to make it, I'll try to make it as agreeable as possible. So I'm going to talk to you about the GridFTP with LVS, and as a replacement of Bestman. So what is Bestman? So it's Bestman, well, a male friend or relative chosen by the bridegroom to assist at this wedding. But according to the LVNL folks, it's the implementation of the SRM protocol, and mainly it's a way to expose your storage system to the outside. What does Bestman provide? So an implementation of the SRM protocol. The users, the virtual organizations, and site only have to advertise one Bestman server and hide several GridFTP servers behind it. So then users can copy files back and forth, just knowing one door instead of knowing the whole array of GridFTP servers. Why to replace Bestman? Well, LVNL dropped support for it in 2012, and since then OSG, I'm part of OSG, have been maintaining it. Experiments and sites still need a way to expose their massive storage systems to the grid. We are in a quest to make the OSG middleware layer thinner and thinner. So OSG will end support for Bestman at the end of 2018 with the end of life of OSG 3.3 release, and then current release of OSG 3.4 does not bring Bestman. So we needed a solution. What is LVS? For those who don't know, it's Linux built virtual server. Who already have heard of LVS or has worked with LVS before? Oh, nice. So the Linux virtual server is a highly scalable and highly available server. You can build a cluster for a service and put several mini servers behind it to make it look like just one. Some of the features is maintaining part of the core Linux code. It has load balancing, and it can discover automatically malfunctioning servers, so it tests them continuously. So if one is not working, it won't send requests towards that server, which is quite useful. So how does LVS work? So bear with me a little bit with this. IP is not a big deal. You send a request to one server and you see your IP packet. If it's IPv4, you do an RPF spoofing here, and it changes the MAC destination of this one, of the same packet to this one, and then when it answers back in the RP protocol, it sends it back to the usual server. How does when LVS meets GridFTP? GridFTP is quite intelligent. So when you do a G-file copy or whatever, and you talk to the LVS server, it does the packet forwarding only the first time. And then on the green one, the control channel is talked directly, and it sends, well, this is my real IP. So it sends it back, and from then all the communication goes between here. This is a feature of LVS called LVS with direct routing. There's another way of you can do LVS with NAT. IPv4 and IPv6 is quite similar, except that when it's IPv6, there is no RPF spoofing because there is no ARP in IPv6. So some scale tests. Well, we all set it up, but we needed to know that it was going to be good enough to replace what Bestman was needed. So we run different scenario conditions: 1,000 jobs, 2,000 jobs, 3,000, 4,000, 5,000, hitting the LVS GridFTP server. We tested with an LVS server GridFTP running on Blade servers with 10 gigabit Ethernet cards, kind of like this regular setup of all the US tier 2s. G-file copy every 10 seconds from our Hadoop server to DevNull. So we really didn't want to mess with the local disk storage. All like the local scratch disk, but we want to see things going end to end, like the usual use case when you bring things out of Hadoop. So how to test it? You use a sleeper pool, not exactly like this one, but like this one. So you, in a worker node, you have real cores. and what we call a sleeper cores. You can do this pretty easily by increasing the amount of, in Condor, you just tell it, oh, I actually have more cores, and just send jobs here that do not use either memory or CPU. So basically, they are just almost not doing anything. But it's good because it tests the whole system end to end, and we can profit from the bandwidth of the whole node. So some of the scale test results. At 2,000 jobs, we got a nice throughput of 30 gigabit per second. Like this is all stacked. So, and this is when, and you can see the load balancing was working pretty well. Like all of the grid servers, GridFTP servers got almost the same requests. And if you want to see something about our scale test, this is in the horizontal line is the number of parallel jobs and the average throughput that we get. And you see that there is a sweet spot here around 2,000 jobs per 2,000 parallel jobs. And after that, actually, the throughput doesn't become better. This is a problem most likely because here we're limited from the worker nodes on how many. So if you land too many of those jobs in one node, you're limited to the bandwidth of that node, not necessarily to the bandwidth of the whole servers. But we call it a day, and the reason why we call it a day is that if you see the usual usage in sites like Nebraska, UCSD is never beyond 2 gigabytes or 4 gigabit in a big day of this GridFTP server. So what we achieved was already 6 times that. So we were happy to call this a day. How am I doing on that? So this is. And you can see we plan that this is going to be what the whole tier 2s will be using. Right now it's only deployed in Nebraska, UCSD, and Caltech, but our plan is to make it, and that's what sites will do since Bestman will do support. There is, the LVS is not that easy to set up, and that's the only downside. There's the system, the sysadmin has to know quite a little bit about network because it gets kind of tricky, especially because CMS and some others are now requesting that these GridFTP doors do IPv6 and IPv4. And then it gets really, really tricky. Some conclusions. The new LVS plus GridFTP server scales to the sites needs of sites. There are more problems that will show up when different sites try to approach this, especially sites with not like newer sysadmins. And LVS and GridFTP has proven effective Bestman replacement. Some acknowledgments that are due because I didn't do this work all alone. Also, I would like to take the credit. Garhan and Brian at Nebraska for coming up with this idea. Terrence, the sysadmin at UCSD, set up the pool and the scale test. And Clifton, one of their students, conducted and documented the large scale test. So I just did the slides. I basically didn't do that much. And if you have any questions, no, this is not, you can reach us here. No. I think it was all clear. Yes, this is the recommended way of OSG for sites, and especially for sites that support LHC sites that still will require Bestman to move to this. There is already documentation. Maybe I should have put a link to it. And yes, this is the way, and we will draw support by the end of the year. So sites better start moving.
At our site, we kind of tried something similar, but we used HA proxy to do the control plane multiplexing. But we ran into a problem where if the user had enabled IPv6 support, it would disable something in GridFTP, and it would always just return the IP or the port and not the data plane's address.
Yes.
And so having the load balancer in between actually and IPv6 client environment variable set would cause it to break because it was trying to talk to the control plane, not the data plane host.
Yep.
Did you find a solution to that?
Yes, and I'll talk to you because part of the solution is not running the LVS directly, but with some patches that don't exist in Nebraska. So part of the solution, yeah, you need some patches to make it work with IPv6. No, I'm pretty sure we did not. But we do know that now it works end-to-end with IPv6 and IPv4, and we tested it. But yeah, that's what I was saying, that this is quite tricky to make it work with both